Okay, this is video number 3, and let's make a quick recap here for what happened in the last 2 videos. We took all odd numbers as input to the function for odd numbers, which said that you take the odd number multiplied by 3, then add 1. The output was 4 plus 6x, which are all even numbers, and what we are going to do now is to take 4 plus 6x and give it as input to the function for even numbers. Okay, and let's see what is the outcome of this. First, let's talk about the members of 4 plus 6x. They are 4, 10, 16, 22, 28, and so on. If we apply the rule for even numbers, it tells you to keep dividing by 2 until you reach an odd number, right? So let's apply this rule. 4, 2, 1, 10, 5, 16, 8, 4, 2, 1, 22, 11, 28, okay, is 14, 7, and as you can see here, not all even numbers of members of 4 plus 6x, not all of them reached the next odd number in the same number of steps. For example, here 4 reaches 1 in 2 steps. Here 10 reached 5 in 1 step. 16 reached 1 in 4 steps, and so on. Not all of them have the same amount of steps. And if we apply the function or the format that we have talked about, that tells you to represent an even number as 2 to the power of something multiplied by an odd number, we are going to find that 4, 10, 16, 22, and all the members of 4 plus 6x are going to be represented like this. 4 is going to be 2 to the power of 2 multiplied by 1. 10 is going to be 2 to the power of 1 multiplied by 5. 16, 2 to the power of 2. 22 is 2 to the power of 1 multiplied by 11, and so on, right? So we have talked about this. We are going to not do this iteratively. We are going to do this in one step. We are going to divide by 2 to the power of that something, that exponent. So that's going to be a problem. Why? Because 4 plus 6x is just a simple linear equation. If we need to divide by a fixed value, I can divide by 2 to the power of 2, and at the same time by 2 to the power of 1. I have to choose a specific value, but unfortunately not all of those even numbers have the same n. So how to solve this? Well, one solution to this is to group them into or according to the value of n. What do I mean by that is to say which members have n equal 1. Of course, this is a small sample, but if you have a larger sample like I did before this video, you're going to find the numbers that you want. For example, those members of 4 plus 6x which are having n equal 1, they are going to be represented like this. They are going to be 10, 22, 34, 46, 58, and so on. If you want to represent them as a sequence, you would say they are 10 plus 12x, where x is just any index. So you start with 10 and you have a step of 12. 10 and then plus 12, you get 22. Plus 12, you get 34. Plus 12, and so on. You have a start and you have a step. that is a sequence. Okay, then for n equals 2, the members are 4, 28, 52, 76, 100, and so on. When we represent them as a sequence, they are 4 plus 24x. I don't want you to get bored, but please bear with me until we reach n equals 6. Eight 4x. Okay, why did I do this seemingly boring manual work? Because I want you to see this by yourself. We have splitted what we have done here, that we have splitted 4 plus 6x into this sequence that's called 4 plus 6x. It has a start of 4 and has a step of 6. Now we have splitted it into infinite sequences where each one of them have the same n. For example, where n is equal to 1, now we have the sequence 10 plus 12x. When n is equal to 2, we have 4 plus 24x. When n is equal to 3, we have 40 plus 48x. When n is equal to 4, we have 16 plus 96x. We're almost there, okay? When n is equal to 5, we have 160 plus 192x. And when n is equal to 6, we have 64 plus 394x. So this is a good step, because now we have maintained the linear relationship. We have maintained linear equations. We still have patterns, and this is the goal of all this approach, is to have patterns and have formulas. It's not easy to deal with something complicated, so we are searching for simple patterns, and linear equations are simple. That's why we have splitted 4 plus 6x into multiple sequences to maintain the simplicity. Many more sequences, actually infinite number of them, but they are all simple. They are all just basic linear equations. So what is the use of all those linear equations? That is the subject of the next video. We are going to find patterns, and we are going to deduce 2 good formulas that I think you would find interesting. So stay tuned, and I hope I see you in the next video. Thank you.